Welcome to our FAULHABER Drive Time. In this video, I want to show you how to use the step mode or the gearing mode of our motion controllers. Step mode is an operating mode where the target position is given by a signal having pulses. So we are counting the pulses and calculate the target position out of this. Whereas the gearing mode is using a quadrature signal, so essentially the signal of an encoder, to control the movement backward and forward. And I once again use one of my demo kits here. This one is having an MC5005, the S version, so having all these screw connectors here, and a 2232BX4 motor here to be controlled. And to create the reference, I'm using an incremental encoder here, so using a DC motor and an IE2 512, and I created an adapter to connect the A and the B signal of my encoder to the I/O connection of the motion controller here. So that's being used for the gearing mode, and for step mode I use the same encoder here, but only a single of these signals. So essentially then the encoder is only used to generate pulses, whereas a dedicated separate switch is used for the direction of the signal, so forward or backward. So that's the setup here. Let's switch to the PC. First, there are going to be two slides to explain what I have to configure, and afterwards we're switching to the live view of the Motion Manager. Step mode or gearing mode are using the digital inputs 1 and 2 to count the pulses. So for the gearing mode, it would be reconfigured to be used as a quadrature counter, or for the step mode, it's counting the pulses of the digital input 1, whereas the digital input 2 is used as the direction signal. So what we have to do is, of course, configure the digital inputs to be used as these counters, and then rescale the values that we get out of the counter to be used as the internal reference. Usually it's position control. So for example, in my demo unit here, I'm having with these linear Hall signals 4096 increments per revolution of the motor. And with my DC motor being the reference here, it's a 412 lines per revolution encoder. So if I want to have a one-to-one movement, one turn of my reference and one turn of my motor here, I would have to rescale the 2048 counts out of the quadrature signal into the 4096 that I need for my brushless motor. Or on the other side here, when it's the single pulse train only used here, it's of course 512 pulses per revolution. And when I want again to use the one-to-one relation, so one turn of my reference of my dial, to move my motor by one turn, it would be rescaling the 512 external pulses to 4096. Maybe be aware of course, speed or position can be used out of this. The digital in thresholds are used here, and please be aware there might be some limits for the frequency of these signals. After configuration of the inputs, what we still need to do is, of course, select the operating modes. That's similar to when using analog signals to control the movement. So what we do is either switch to analog position control or analog speed mode here and select the appropriate source. In that case, it would be the reference encoder here that is to be used. So here is the Motion Manager. The drive is already configured and tuned here. And what I have to do is, of course, configure the IOs. So here's my dial, the DC motor and the encoder, and it's connected to the IO connector here. And in that case, gearing mode, so using the A and the B signal of the encoder to control the speed and the direction of the movement. Configuration is done using the Drive Functions window. And the configuration of the encoder used here is down in the signal management part of the Drive Functions window, and that's here, the encoder page. And first of all, we have to select the operating mode here for the reference encoder. In that case, it's an incremental encoder, no index signal present, and of course, no index signal used for such gearing mode. we apply the setting and have to rescale the counter here. Here, in that case, my dial is having an incremental encoder having 512 lines per revolutions. This would give me 2048 increments per single turn of my dial. And depending on how I want to move my motor in the demo unit, I have to rescale here. And the idea is always the same. So divide by the number of pulses that you get from the external source and multiply with the number of increments that you want your motor to move. In that case, let's have a slow one. So use 512 lines that we want to move the motor here. And then we are done with the encoder and can send. And then, of course, I have once again to select the source that I want to use here. So the target source for the position in that case is this incremental encoder, send, and then switch to the operating mode. In that case, it's analog position control. Once again, send the parameter, and of course, you would like to save it if you want to have this permanent, and then start the control and the graphical window here and move the motor. And so you can see now it's moving upwards, and when I turn the dial in the other direction, it's moving downwards. That's it for the gearing mode. So now here the same for the step mode. I had to change the adapter because in that case only a single of the two encoder signals is used to generate the pulses, whereas a dedicated switch is used to switch between backward and forward movement. Configuration is only a small change here, once again done using the drive functions window. And it's in the encoder section here once again, but we do no longer have an incremental encoder here, but we do have a pulse and direction signal. So one be changed here, apply the one, and we might have to reconsider the scaling here, because using a pulse signal, a single one only, of course there is no quadrature count, so I do get now these 512 pulses per revolution of my dial. And when, in that case, for example, I want to have a single turn of my motor out of a single turn of the dial, with these linear Hall signals, it's 4096 increments per turn of my motor. So this would be the appropriate scaling here. I send it, and otherwise the settings are still fine, because it's still the incremental encoder interface that's used here as the target position, and the operating mode is still the analog position control. So I can close here and watch the movement and start the control, and let's see the motor moving here. So now it's moving upwards, and when I change the direction here of my dial, the motor is still moving upwards because it's still generating pulses, and the direction of my dial doesn't matter because I have to use the switch here in order to reverse the direction. So let's do this, and then it's moving in the other direction. So this is pulse and direction, very similar to what is used in the environment of stepper control, and this can be emulated by our motion controller too. That's it for the step mode and the gearing mode. And of course, if you got any questions, as always, contact our local sales team or our MC support team. Otherwise, check back with our channel and leave a comment. And thanks for watching, and bye.